Hey all, thanks for coming along. Yes, I've put about 4 different topics into my title so that I could definitely have something to talk about. The unfortunate thing then is actually trying to squeeze it all into a half-hour talk, so I'm going to try and rush through a few things here. So first up, just API first development or design first development has kind of emerged with domain-driven design, Go and Goa. So hopefully one of those things is of interest to you, and hopefully I managed to talk something about it. So why do I care? Well, like probably many of you in the room, wealth of experience behind me, worked with a bunch of languages, frameworks, web APIs, written a few of those along the way, some good, some bad. And generally I've always had this kind of fascination with the way that you kind of interact with your code as a developer and how that then informs the actual how you solve the business problem with those things, but actually then also like how you can actually shoot yourself in the foot so much. So whenever you come to switching out a framework and you realize, oh my word, I've just baked everything that I know straight into the framework logic, or you're switching out DB and you realize, oh man, I've put so much in there. So these things have always kind of fascinated me as a little bit of like, how do you make life better for your future self? And I guess more recently, kind of looking at, as microservices have become a thing and looking more at API design and how important that is, definitely become even more then along those lines. And additionally, not just a shameless plug, but I work at a company called Flexera. We are sponsors of this event, and is also one of the reasons why I'm speaking. Flexera is it's a technology asset management business. I'm going to have to read this to get it word perfect. We help many of the world's largest well-known companies get insight into their IT estates, manage their spend on software licenses, SaaS and cloud, provide automations to implement immediate corrective action in order to get the most out of their IT investment, which is a mouthful that apparently some people in our company have memorized, but I have not. The long and short is that IT asset management, not exactly the most exciting sphere in the world. However, the technology to kind of make it work, like so many spheres that I'm sure we all work in, is actually quite an interesting problem to kind of work with. One, you have to kind of actually figure out what's there, and these companies are coming to us, some of the largest companies in the world, coming to us because they literally have no idea what they've bought, what they run, what their current state of play is, and so they're coming to us to try and figure this stuff out for them. So it's a difficult problem just to begin with. You add into that the mix of all the various different applications and the business problems that are trying to be solved, the domain problems. So it's licensing for like a laptop and an application on a laptop, the same as the licensing that needs to be applied for example, a massive Oracle cluster and the usage patterns that are being used there. Is that similar to the spend stuff that's maybe within your AWS account? Or does AWS work the same as Azure? So all the multitude of little different idiosyncrasies that are in there. And that's even just that like kind of licensing side of stuff. Bring in risk and the multitude of different things there. Is your software beyond end of life? Are there vulnerabilities attached to that? What's your actual threat surface? And you end up with actually one massive kind of problem space that looks like the same domain, but actually turns out isn't really, because they're all trying to solve little kind of little parts of that. So why design? Why design up front? The business will usually come back and say, well, is that not a bit of a waste of time? We don't do waterfall anymore, we're agile now. But the reality is that, as the quote says, we're always designing, whether we think about it or not. So whenever we just are reduced to code monkeys, shifting tickets across the board, we might not be thinking about the big picture, about what is actually, how does this might and touch other things, other parts of the system. And so we end up just kind of tagging on features, ticket by ticket. And we end up with the famous big ball of mud. Usually applied to something like a monolith, and we're all microservices now, so we don't have this monolith. Forgetting that the same thing can apply, and you just end up with an even more complicated distributed monolith. So how do we actually then start to figure this out? How do we actually think more cleanly about some of this stuff? And it turns out that this isn't a new problem. Turns out way back 2004, I believe, this was already a huge issue. Never mind the levels that additional software has kind of come over in the last 15 years. Guy Eric Evans brought out this book, Domain-Driven Design, Tackling the Complexity at the Heart of Software. So just acknowledging the fact that software is complex. At any sort of level of beyond trivial, it becomes difficult. How things interact and play together, how do you change bits of the system without it infecting other bits? And the whole book is trying to get to a point where it's trying to teach patterns and that will help solve some of that complexity, or at least distill it down into smaller chunks. Now, ironically, the book itself is pretty hard going, and it's quite a complex read. Thankfully, follow-up books have appeared. There was an image somewhere that compared, the JavaScript, the good bits. I'm sure you've all seen that picture. And there's a similar kind of thing with this. This is a good chunky book, but there's little ones now that have come out kind of explaining it a little bit better. So about 6 months ago, Flexera decided, okay, we're trying to unify a lot of our models here across the company. And we've learned that, okay, one big model isn't going to actually satisfy us. We need to break this down into smaller chunks. And so we're going this DDD approach. So caveat, I'm pretty new to some of this stuff, so I'm going to race through it in the hope that you don't realize that I'm spoofing. So what's this all about? And the clue's in the title. It's the domain and the design. The domain, at a very simple level, is the problem you're trying to solve. So it's not your whole business domain. It's trying to narrow it down into something manageable. And the design is the effective design that's going to actually be the solution to that problem. And at the very heart of the whole thing is those kind of two simple contexts. So where do we start? Because you day one, new project, you know nothing. How do you actually start writing software? And the book kind of breaks down this design phase into two. You've got your strategic design, you're kind of forward thinking, you're planning the big models, and then you've got your tactical design, which is actually how you're going about implementing this stuff. That strategic design is all about two things, and more buzzwords. It's about your ubiquitous language and about your bounded context. The general idea is that you get the domain experts into the room, you get your engineers into the room, and you get them to crunch, or to do a process called knowledge crunching. So just literally everybody throwing out everything into the table to try and get to some sort of consensus. And the idea behind that is that you come out the other end with this thing called the ubiquitous language, and some sort of idea of what the problem is that you're solving. So let's drill down slightly further, because those terms are a bit meaningless in themselves. The ubiquitous language is the idea that, well, it's recognizing the old computer problem, or computer science problem, two hard things in the world. And I've forgotten the first one, and naming things. Nerves are great. But the idea that naming things is difficult, and actually as software engineers, we tend to be a bit rubbish at it because we're not necessarily embedded in that domain. So the idea behind ubiquitous language is that we have our names almost defined for us. The business will have names for things. We should use those. So whenever we start looking through an application, 6 months down the line ourselves, or a new start comes in to look at it, if they understand the business at all, then they should be able to pick up the concepts that are going on within that code. So already we're kind of simplifying some of the stuff. The other idea behind that then is that whenever we start talking to some of the rest of the business, we're using the same language, and we're not talking across each other. Anybody who's been in any project of any size will have experienced that. Different names used for the same terms, different terms used for the same things. It's a bit of a hellish nightmare. And so the idea here is that everything kind of comes in together. But there's actually a flip point to that as well. What falls out, or what gets filtered out, is the stuff you don't care about. So there might be a whole bunch of stuff that seems relevant to begin with, but actually isn't actually part of the problem-solving bit. And that's where your bounded context comes out. So it's not just about defining all the names up front, but it's actually also around this idea that there is stuff we just don't care about within this model. And so we're trying to hone it down into as small a thing as possible. So again, if the domain is the problem, the ubiquitous language is how we talk about that problem, then the bounded context is literally the solution. So an actual diagram of sorts for a change. The idea here is, and you'll notice that there's this little switch between customer and product. Both kind of have this idea of customer and product. But within the sales context, it's a very different thing than within the support context. Now, they may actually be the same customer, but how you actually need to model that customer is very differently within a sales context. You don't care anything about kind of future stuff once that sale's made. That's up to the support people to worry about. And the support people don't really care about any of the sales process either. Equally, the product as well probably comes in slightly different guises. The sales side, they're going to care about like which products they're selling, the pricing and stuff of that thing. And the support, they're probably going to care more about some of the engineering stuff, the defects and whatever, and keeping track of that. So this is kind of one of the big ones, and I come from a background of very heavily on the dry principle of not repeating yourself. And this is kind of not necessarily throwing that to the wind, but it's effectively saying it's not the only tool in your toolbox, and sometimes it's a little bit gets in the way. So in this case, your customer will not necessarily hold all of the business logic for that customer. You actually split it in two with some sort of reference between them. And for anyone who's interested, they do offer a whole bunch of different options around how you might do those interactions, depending on how tightly tied those bounded contexts are. So continuing to move on. On the other side of the fence then is the tactical side of stuff, the tactical design. And this is actually the more on how we might actually implement it as software engineers. At a very kind of quick way, simple kind of hone in on some stuff. The heart of everything is an aggregate. An aggregate is made up of one or more entities or one or more value objects. Value object being something that you would expect. It's a value, it's immutable. And an entity is probably something more that you reference by an ID. So there's a chance that that's going to change. So your value object might be like an actual address. That address isn't really going to change. It shouldn't change. However, the entity might be a user, for example, and the aggregate may well be then the interplay between that address and the user. The aggregates themselves then trigger domain events, which is how the rest of your systems can kind of figure out what's going on with those aggregates. I should say the aggregate itself probably is just like an entity. It's just that it's slightly higher form. And the other side of stuff in terms of things kind of wrapping that up is this idea of services, application service, domain service. Now, funnily enough, this came out kind of 2004, so kind of before the microservice buzzword. However, it turns out that they play in quite nicely together. Following people have kind of said that quite often those shared terms are problematic, but actually in this case, it probably is something like a microservice. And your aggregates then are the methods and models that you kind of have within each of those. Again, there's a bit more to it than that. We've got all these other things that may be familiar from other kind of architectural processes. So you've got your factories, your repositories, your layered architecture, and some UI and whatever else. So that's the kind of the nuts and bolts at a very quick clip. So you've got the DDD is all about your domain, defining what your domain is, your problem is, and your strategy to get to an effective design through strategic design and tactical design. So I mentioned, speaking of microservices, I'm sure most of you in the room have come across Go before. Big blurb about what Go is from Wikipedia. The important bit here from my point of view is that it was developed by Google, and they used it. Depending who you talk to, it was designed to kind of act as these network daemons, just running within their system, and the early precursor to Kubernetes. And it kind of had that purpose. It was kind of small, it was simple, it could run simple tasks over the network and move on. So there's a big play in with microservices in Go, but it's not exclusive. Use your own language, whatever it may be. And then on to this thing called Goa. Kind of a framework, kind of a not. But it tries to marry that idea of what DDD is trying to accomplish and apply it to an actual implementation. So it comes with this design-first approach. And so the idea is that, as the quote here is kind of saying, it's all well and good that we can kind of map out the world and have our domains and they're all neat and tidy and we've got them signed off by our domain experts and whoever else. But if they don't actually make their way into code, then they're a bit useless. And so much of the disconnect between what is a very good idea and actual implementation can quite quickly fall down in that first step. So what Go tries to do is marry those two. It does this by a couple of different things. One, it's got a DSL to help define what your API is or what the model is for that microservice. Off the back of that, it does some code generation for you to create some of the tedious things behind defining defining the models and defining the servers and things behind the scenes. It allows you to be transport agnostic because it's code generation. It allows you to pretty much write your own generator for whatever your thing may be. The two out of the bag ones are gRPC and HTTP, which should get you pretty far to begin with. And it also then promotes this kind of separation of concerns. It doesn't want to do too much. So the actual implementation of that design should be handled by software engineers. They're the people who know what they're doing. They know, for different levels of that microservices lifecycle, it may need switched out to a different database. Maybe there's a service that's spun up behind the scenes to kind of handle some other part of the system that they didn't have to begin with. Stuff changes behind the scenes, and so software engineers should be left to do whatever they need to do within there. So from that point of view, it's not like something like Django that will go off and generate your DB for you and a direct mapping to a database. The idea here is to be agnostic of everything beneath. It's just giving you a couple of interfaces and a couple of structs that you can then go on and play with. As a code generation tool, as I was kind of saying, not only is it in line with the code is defined as a DSL, and then the engineers have something to work with. You can actually then also start to auto-generate documentation off the back of it. As we all know, documentation is where ideas go to die. So the idea behind this is that your documentation is always up to date. If you make a change on the API, you've made a change to the documentation. And the two are married and closely held together, so they're always up to date. And then finally, as I was kind of saying, the idea behind Go is to do as little as possible and then get out of the way. Having said that, there is a plugin architecture for it, so you can kind of go down that kind of route if you want to, of generating more than what is required. I think for a previous version, there's definitely a mapper to the Go ORM. So yeah, there's different kind of ways that you can kind of then play with that. But that's at a very, very high level. So hopefully going to try and take 10 minutes if the demo gods work to kind of give you an actual walkthrough of how some of this might work. So take a seat. So I've fairly minimal, and I should probably get rid of that. Using GoMod, best practice at the moment. All I've got here is a little calc package, doing not a lot at the minute, obviously, empty package. So what I'm going to do is just create a new package within that called design. And within that, again, actually something to put some code in. It just realized.
Thank you.
That too far? Is that okay?
No, that was really good.
So just kind of basic stuff to kind of get us going. We need to import Goa itself. Ignore the dot notation. It just makes the DSL a bit easier to read. So we've now imported the DSL, have all the various methods to kind of work with. So up first is just to define the API itself. And we're going to create a need that to get out of the road. And very basically just start with some of the simple stuff that we might want to put in there. So and maybe we want to put in a description. If I can type.
It's only because people are watching you. Suddenly your finger's not working.
It's the way it goes. Yeah. There we go. So that's the very basic. And obviously, if we're going to have an API, we probably want to have a server to run some stuff on. And we'll call that the calculator. And again, we might need to define what that actually looks like. So we need a host. And we'll call it localhost, and that localhost just needs a URI. And there we go, we've got a service that will run a server for us. Now, that's a bit useless because it doesn't do anything. So the next kind of step is then to think about what actually is going on in that service. So start a service, let's call this one calc to make it a bit easier. And of course we need to define some methods that's going to go on. So what does this thing actually do? What is the purpose of this? So it's a calculator service, so what would be really handy is a method that adds things. That's probably going to be fairly handy functionality for a calculator service. And this method is probably going to want a payload of sorts. So we'll call this one A. It takes an integer, which is the left operand, and it also takes on the right hand side another integer, so we can add the two things together. We probably also want to return a result of some description, so we just need to define that there's a result that comes back and it's of a type integer, and we probably want to throw potentially an error or two, so we'll put in one here just to kind of call it out. So this in itself is still not really doing a lot. This is just defining what the kind of abstract model looks like, and the abstract, I guess, ultimately interface in a Go term. So we also then need to, I've done that wrong, just ignore me a second. Because turns out I should have typed all this beforehand. I'm always at a little bit of a loss. Do you type it up front and talk through it, and then people switch off, or do people like watching you make mistakes? You know, it's, and that comes up into there. So we're going to start off just with a simple HTTP service. So we need an HTTP to actually implement this thing, and we need within that we need a get method, and we just simply, similar to other frameworks you've probably used, set some parameters on that. And then we also want a response of status, okay. And that's pretty much us done from a standpoint of defining what this thing's doing. So as I said, we've got this service, it's got a method, it's got some sort of, if the business domain was a calculator for some reason, then we have this method that's going to start getting us down that line. So what's up next then? So we've got that defined. Just nip over here, and probably going to need to bump the size somewhat again. Ignore that. So I said it came with some code generation options here. So we've got this tool, Goa, installed. It's got a bunch of different commands in there to kind of get us moving. But basically what we want to do is generate the boilerplate behind the scenes. So we generate the package by the Go name. That'll take a little second because there's some connection stuff going on, just to make sure all the packages are there. And as you can see, it's reporting that it's created a bunch of work behind the scenes. And also, interestingly, this open API stuff at the bottom. So we take a quick look in at what it's generated. We've got two packages, the calc package, which corresponds to the service we've just written. And within that, then you'll find things like your interfaces and your structs, depending on what you've defined in the interface or in the DSL. I've just got a 5-minute warning, so I'm going to keep on moving. next thing is that generated code is everything you kind of need to get going. So you could plug that into whatever at this point. But kind of helpfully, Go also then provides us with something to kind of get moving quickly. And so we'll quite happily go off and generate some example code for us. Should say the generated code needs to get regenerated every time you make a change to the DSL, but that kind of makes sense. This example code will fall out of sync, and it's probably up to you to kind of keep it up to date beyond that. This is just a bit of an example to kind of get you moving. So as you see, we've got a CLI randomly created, so we've got some packages going on in the background. So if you're using different Go programs to talk to each other, you actually have a client library that you can import and make use of. And the CLI does that. But if we move into the actual command for the calculator and do a quick ls, we've got our main stuff, which is the stitching together of all our bits and pieces to create our server. So if we go build and run the thing, we'll see that we're now running. And if I do probably not going to get to that step. Add 1, 2. We'll see that it makes the request fine, but it's obviously coming back with 0 because we've not actually implemented anything yet. Because again, that's up to us. The helpful example has created this little file for us and has this function add. So that sounds like it would be like your adapter within something like the clean architecture, controller within your MVC, that sort of thing. And you've got access then to the payload that's come in. So if we just have a very quick and dirty, we could obviously abstract this out into some other business layer if we really wanted to. But for the purposes of demo, we'll do a quick save there. And there's no need to touch the generated code for this, obviously, but we do need to rebuild what we've just written. And lo and behold, we have a service that starts to work. The next bit that I talked a lot then about the documentation, so it probably makes sense that we could export that file as part of our CI/CD, plug it in somewhere central, have it all living nicely. But we could also then just, because we're creating servers here, we could run it as actually part of, I'm not going to get to this. HTTP open API.json. Well, you'll have to believe me. Time is up, but you can then just start to generate, or it will export that as an endpoint. You can throw that into any of your Swagger documentation, make it all pretty nice, share that with the rest of the people in the APIs, other developers, maybe the product owners, who knows. Definitely people like support. So yeah, that's a very quick introduction, as well as the kind of basic types there. You obviously can define your own types, make those purposeful, meaningful, not just kind of relying on your basics. So thank you very much. I am out of time. Feel free to take questions after.